graders, and welcome to your lesson on adding and subtracting integers. So if there's ever a lesson I want you to remember from what I've taught you, this is the one, okay? This is the lesson that affects everything else you learn from here on out, and that I've seen kids and even adults make mistakes time and time again. So really pay attention. We're going to dig in, and I'm going to teach it to you the same way so you can know it even from an early age. The first vocab word we need to know is absolute value. Absolute value refers to how far a number is from zero. So here I've got a number line. If I was looking at the number 3 and I asked you how many spots it is from 0, we would count back to 0 and we would count 1, 2, 3. So the absolute value of 3, which can be shown here with these two straight lines, whenever you have two straight lines on either side of a number, it's asking for its absolute value, is 3, because it's 3 spaces from 0. Now, what about the negative 3? Well, over here, I've got negative 3. How many spaces is negative 3 from 0? It's 1, 2, 3. So the absolute value of 3 and of negative 3 are both 3. I've seen a lot of students think that absolute value means the opposite. So when they see the absolute value of negative 3, they put 3. But when they see the absolute value of 3, they put negative 3. And that would be wrong because it's asking how far from 0 it is. The only way that it could ever be a negative is if the negative was outside of the absolute value bars. Because then you would find the absolute value of 3, which is 3, and then multiply it times negative 1, which would give you an answer of negative 3. But for the sakes of this lesson, you don't even have to worry about that. So we can cross that part right off. It's always going to be a positive. So what about negative 17? How far from 0 is negative 17? 17. How far is 17 from 0? 17. So both of them are going to have an absolute value of 17. The next vocab word we need to know is integers. Integers refers to all positive and negative whole numbers and 0. This is also sometimes worded all positive numbers and their opposites and 0. Okay? Now, here's a big bold statement you've never heard before. There is no such thing as subtraction. No, really, I'm serious though. Really, subtraction is just adding the opposite. Remember when we did dividing fractions and I said there's no such thing as division. We're just multiplying by the reciprocal, right? So in this case, instead of doing the opposite of division being multiplication, we're going to be doing, there's no such thing as subtraction. We're just adding the opposite. Well, what does that mean? I'm about to explain it to you, okay? So here we make subtraction problems into addition problems by keep, change, opposite instead of keep, change, flip. So what does that look like? Let's do some examples. Here I have 7 minus 5. And you're like, well, I already know the answer to that. That one's easy. Well, let me show you how we can make this into an addition problem. So if I do keep, change, opposite, the 7's going to stay the same. I'm going to change the subtraction to addition, and then I'm going to take the opposite of 5. So the opposite of 5 is negative 5. So 7 minus 5 becomes 7 plus negative 5. And we'll know what to do with this on the next page when we get to it. What about this one? Well, keep, change, opposite. Negative 3 is going to stay negative 3. The subtraction is going to change to addition. And 2 is going to change to negative 2. This one, pause the video, try it on your own, and then hit unpause and see how you do. Keep, change, opposite. So the negative 7 became addition. Let's jump into page 2. So once you've made it into an addition problem, this is where it gets fun. When adding and subtracting integers, always make it into an addition problem first. So then, if they have the same sign, if they're both positive or they're both negative, find the sum. Same sign, find the sum. If they have different signs, okay, then we need to find the difference. Here, make a note that they're going to keep same sign. And here, they keep the biggest numbers sign. All right, let's jump into what this looks like. All right, first we're going to do ones with the same sign because this is really easy. So if I've got two positive numbers here, if I've got 3, okay, so I added 3 onto the number line, I'm here, and then I add 5 more, I'm still going in the same direction because they're positive. So I'm just going to find their sum. 3 plus 5 is 8, right? And they keep the same sign. They're still positive. If I've got two negative numbers, well, even though they're negative, they have the same sign, -3 and -5. So the same thing is happening here. I go to -3, and then I'm still going in the same direction, another 5. So as we can see here, because they're going in the same direction, we want to find the sum, which is 8, and then they're going to keep their same sign, so they'll be -8. So that's pretty simple. If I were to model that with chips, okay, yellow is going to be positive and red is going to be negative numbers. So if I had 3 positive chips and I added another 5 yellow chips, well, then when I count them up, I've got 3 plus 1, 2, 3, 4, 5, which is 1, 2, 3, 4, 5, 6, 7, 8 yellow chips, right? And likewise, if I had 3 red chips and I added in 5 red chips, well, then it would just be 8 red chips. So they're going to keep their same sign. I'm finding the sum. What gets tricky if I have 2 different colors. So let's say that I had +3 and then I added a -5. Well, I want to find the absolute value of both of these numbers. And what that means is I'm basically lining them up. So I've got +3, I've got 3 chips. And I've got -5, which means I've got 5 chips. When I line them up this way, I can see that these will all cancel out. A positive and a negative, they cancel each other out. They equal 0. So in this case, these are all going to go away because they all canceled. So what's left? 2. And what color is it? It's red. Why is it red? Well, it's red because the bigger number, that like a bigger absolute value, was 5. So I found the difference. I did 5 minus 3, which was 2, and then it's red because 5 was the bigger number. So my answer would be -2. If I had -3 and I added +5, well, they're different signs, so I'm going to find the difference, which means 5 minus 3 gives me 2. And this time, it's going to be +2 because my positive number was bigger. Let's look at it on paper. So here on the number lines, they show that they've got, you're going -3, so I was here, and then I add 5, and this kind of undoes itself. If I went this way and now I'm going this way, really, it just matters how much I've gained. So it's finding the difference. Here's our example problems, all right? If it's addition, I leave it as it is, and I can use parentheses to really show myself what those signs are. So here I've got -4 plus -3. They have the same sign. They're both negative. Same sign, find the sum. 4 plus 3 is 7, and they're going to keep their sign. They would all be red chips. It would be 4 red chips plus 3 red chips. What about this one? 7 plus -2. Well, this would be 7 yellow and 2 red. Different sign, find the difference. So I've got their absolute values of 7 and 2, and I'm going to subtract them. So that's finding the difference. 7 minus 2 is 5. And then I'm going to give it the sign of the bigger number. So 7's bigger and 7 is positive. So my answer is +5. What about this one? Okay, so this one, I want to make it into an addition problem. So I've got keep, change, opposite. This is going to be 8 plus negative 14. So they have different signs. I'm going to find the difference. 14 minus 8, and remember these are the absolute values, so I don't have to worry about that negative 14 here. So then from there I got 6, and because the bigger number was a 14, so there would be more red chips, it's going to have a negative answer of negative 6. All right, I think you've seen a lot of examples, so pause the video, try these ones on your own, and then see how you did. So here I've got keep, change, opposite. 10 plus 3 equals 13. Here I've got negative 5, change, negative 3. Same sign, find the sum. So 5 plus 3 is 8, and they keep their sign, negative 8. Here I've got, it's already addition, same sign, find the sum. 7 plus 1 is 8, and they keep their sign. So I know what you're thinking. You're thinking, I never knew that addition and subtraction was going to be so difficult, but it actually is very difficult. And that's why we're going to take a lot of time to practice it together, okay? You'll get there. Go ahead and finish those problems, and I'll see you in class.